Let's go over the exact questions here as part of the laws of motion chapter. Here again, I have gone ahead and solved these questions, and but we'll go through them in detail on how what's the rationale behind the solution. We'll go through them all in detail for every question. Okay, so the first one, an object experiences a net zero external unbalanced force. Is it possible for the object to be traveling with a non-zero velocity? If S, state the conditions that must be placed on the magnitude and the direction of the velocity. If no, provide a reason. So what we are saying here is that an object experiences a net zero external unbalanced force, which means that there is no real external intervention, right? That there is no real non-zero unbalanced force, which means that there is no external force that is acting on that body, but still can the body be in motion, that is with a non-zero velocity. And yes, this is what was argued by Galileo and eventually formalized by Newton's first law, which stated that an object can be at rest, it will continue to be at rest, and if the object is moving, then it will continue to move, right? As long as there is no real resistance or any other opposing force in the medium. So yes, the condition is that if the object is already in motion, it means that it will continue to move with that non-zero velocity, even though there is no net zero external and unbalanced force, right? So that's the condition. The condition is that the object should be already in motion, and if that is there, then the object can travel with that non-zero velocity. When a carpet is beaten with a stick, dust comes out of it. Explain. So let's consider the carpet to be like this. It's a flat. A carpet is flexible. It's probably a cloth or something, so it is flexible, right? So before beating the carpet with a stick, you have the carpet, and there are dust particles that are also out there. Now both of them are at rest, right? Both of them are at rest. The carpet is at rest, and so is the dust particles. Now, when you suddenly hit the carpet, what happens is the carpet goes into motion, right? What was at rest, the carpet bends, and which means that the carpet starts to move. But the dust particles, for a brief period, they'll tend to be at rest, right? They'll tend to be at rest because they were at rest, right? So the dust particles will, for a brief moment, will stay on top of the carpet, and as the carpet comes back, they'll hit the dust particles, and the dust particles will also start to move. Right? So that is why the dust comes out of the carpet when you suddenly hit it. It's again based on Newton's first law, wherein an object that stays in rest will continue to be at rest. So when you suddenly hit the carpet tends to move, but the dust particles for a brief period they'll tend to be at rest, and that's why they are away from the carpet. Why is it advised to tie any luggage kept on the roof of a bus with a rope? Okay, so consider this to be a bus, and you have a luggage on the top, and why is it advised that it has to be tied with a rope? What will happen if you don't tie the bus? What will happen if you don't tie the luggage without the rope? And let's think about a scenario of the bus is at rest, and you have kept the you have kept the luggage on top of the bus, which is also at rest. Now, what will happen when the bus suddenly accelerates? When the bus suddenly accelerates, just before it accelerates, both the bus and the object that you place on top of the bus will be at rest. But the moment when the bus accelerates, the top portion, the luggage that is, if it is not tied, what will happen is the top portion will try to be at rest because it was at rest, so it will try to be at rest. Especially if the friction is very little between the object and the bus, that luggage that you place on top of the bus is going to stay at rest. And if the acceleration is too fast, then the object will fall behind the bus, right? Because it will tend to be at rest, and the bus will anyways would have moved. So same is the case when the bus is moving and when you have kept the object on the top. Both of them are at motion, and when the bus suddenly comes to a stop, the luggage on top of the bus will continue to move, which means that it will fall in front of the bus, right? If at all the bus has come to a sudden halt. So Newton's first law, and that is the reason you need to either increase the friction between the luggage and the bus, or tie that. The safer way is to tie the luggage so that it doesn't move. A batsman hits a cricket ball, which then rolls on a level ground. After covering a short distance, the ball comes to rest. The ball slows to a stop because the batsman did not hit the ball hard enough. Velocity is proportional to the force exerted on the ball. There is a force on the ball opposing the motion. There is no unbalanced force on the ball, so the ball would want to come to rest. So, similar to how the marble experiment was conducted by Galileo, though Galileo argued that the marble would continue to roll eternally, it does come to a stop because of the resistance of the medium. So in this case, though the ball is hit on a level ground, after covering a short distance, it comes to rest because of the friction provided by the floor, right, by the ground. So that tends to stop the ball. If there is no friction, or if the medium is free of any kind of resistance, then the ball would anyways continue to keep moving. A truck starts from rest and rolls down a hill with a constant acceleration. It travels a distance of 400 meters in 20 seconds. Find its acceleration. Find the force acting on it if its mass is 7 tons. Okay. So here we are talking about an object that is weighing 7 tons, right? So the mass of the object is 7 tons. 1 ton is 1000 kgs. So mass is 7 times 10 cube kgs. Now we are saying here that particular object starts from rest, which means that the initial velocity of that object is 0, right? So u is taken to be 0. Now, once it starts from rest, it rolls down the hill with a constant acceleration. It travels the distance of 400 meters in 20 seconds, which means that the distance traveled is 400 meters. The time taken is 20 seconds. In all the case, it is very clearly mentioned that the truck travels with a constant acceleration. Now, we know that from the second equation of motion that we studied in the earlier chapter, we know that the distance traveled is ut plus half at square, right? So, if you substitute all these values here, s for distance, and u for the initial velocity of 0, t for 20 seconds, we know what the acceleration is. The acceleration comes down to be 2 meters per second square. Right. So this is your acceleration. Now, once you have the acceleration, we can figure out the force. Force is nothing but the mass times the acceleration. So which in this case is equal to 2 times the mass, which is 7 times 10 cube kg, which is 1400 newtons. A stone of 1 kg is thrown with a velocity of 20 meters per second across the frozen surface of lake and comes to rest after traveling a distance of 50 meters. What is the force of friction between the stone and the ice? So here in this case, we are throwing a stone on ice, right? So consider this to be the stone and this is the ice, right? So this stone is thrown with a velocity of 20 meters per second. So it starts with 20 meters per second. And it comes to a rest after traveling a distance of 50 meters, which means that after 50 meters it comes to a rest. So in this case, the initial velocity of that stone is 20 meters per second. The final velocity v is 0 meters per second, and it came to rest. It came to a complete stop after 50 meters. So the distance is 50 meters. So with this, we know that we can from the third equation of motion, we can find out the acceleration, right? The reason we need to find the acceleration is it's only through acceleration and mass that you can find the force, right? So the third equation of motion is 2as is equal to v square minus u square. With this, if you solve for a, you will find out that a equals minus 4 meters per second square. So which means that it is a negative acceleration because something is not acquiring additional velocity. Something is losing velocity to come to a full stop, right? So that is why the acceleration of this stone is negative, which is minus 4 meters per second square. Now, if you really calculate the force exerted by this particular stone, it has to be MA, which is 1 times minus 4, which is minus 4 newtons, right? So that is the force that exists. So the force of friction. Now the question is not the force exerted by the stone on the ice, but the force of friction between the stone and the ice, which means that the opposing force, which has to be the opposite force, which is minus 4, which is negative of minus 4 newton, which has to be 4 newtons. So the friction is actually 4 newtons. 8,000 kg engine pulls a train of 5 wagons, each of 2,000 kgs along a horizontal track. If the engine exerts a force of 40,000 Newton and the track offers a frictional force of 5,000 Newton, then calculate the net accelerating force and the acceleration of the train. Okay, so in this case, we see that the engine is of mass 8,000 kg. So let's consider the mass of the engine to be 8,000 kg. And the wagon, each of them are 22,000 kgs, and there are 5 wagons, which means the total mass is 10,000, right? 10,000 kgs for the wagons. So the total mass of the train is the mass of the engine plus the mass of the wagons, which is like 18,000 kgs. Now we see that this if the engine exerts a force of 40,000 newtons, and the track offers a frictional force of 5,000 newtons. What is the net accelerating force? So think about it as your train is moving with is exerting a force of 4,000, and your track is providing a resistance of 5,000, which means that your net unbalanced force is actually 40,000 minus 5,000. So your total unbalanced, your net unbalanced force is 35,000 newtons, right? So that is your net accelerating force, right? Now, what is the actual acceleration of the train? We know that we know that force is mass times the acceleration of the train, and we know that the force we just calculated as the net unbalanced force is 35,000 newtons, and we know that the total mass of the train is 18,000 kgs. So acceleration is 35,000 by 18,000 meters per second square. That is the net acceleration of the train. Question number 8. An automobile vehicle has a mass of 1,500 kgs. What must be the force between the vehicle and road if the vehicle is to be stopped with a negative acceleration of 1.7 meters per second square? So here we know that the mass is 1,500 kgs, and what must be the force between the vehicle and the road if the vehicle has to be stopped with a negative acceleration. So here the acceleration is given to be minus 1.7 meters per second square, which means that you can quickly calculate the force, which is nothing but mass times acceleration, which is minus 1.7 times 1,500 newtons or kilograms meters per second square. What is the momentum of an object of mass m moving with a velocity v? So we knew that it was the most fundamental property of an object in motion, and it is mass times the velocity. That is the momentum, and it has a letter of p, right? So the answer is p, which is mv. Using a horizontal force of 200 newtons, we intend to move a wooden cabinet across a floor at a constant velocity. What is the friction force that will be exerted on that cabinet? Okay. So let's go through this. So there is a horizontal force. Using a horizontal force of 200 newtons, we intend to move a wooden cabinet across a floor at a constant velocity. So we are on a horizontal floor, and we are pushing 200. The horizontal force of 200 newtons is being applied here constantly, right? So which means what will happen when you apply a force constantly on a particular object? The object will try to accelerate, right? And which means that it will try to acquire additional velocity every unit in time, right? If you continue to apply that force, right? Now, if we intend to if at all this object had to move in spite of applying this this force, if it has to move with a constant velocity, which means that it should not accelerate, which means that it has to be balanced by the friction, right? Now, what should that friction be? The friction should the frictional force should be such that your net balanced force is actually zero, right? Only when the net only when the net unbalanced force is zero, only then your object will move, but it will not accelerate, right? So for the net unbalanced force to be zero, it means that your frictional force should completely balance out the force in which the horizontal force that has been applied here. So the friction should actually be minus 200 newtons. Only then your net unbalanced force becomes zero, so that your object continues, your object doesn't accelerate, but moves with the constant velocity. So let's just do one more question, and then we'll possibly wrap up, and we'll do the remaining ones in a separate video. Question 11. Two objects, each of mass 1.5 kgs, are moving in the same straight line but in opposing directions. The velocity of each object is 2.5 meters per second before the collision, during which they stick together. What will be the velocity of the combined object after collision? Let's consider the two objects to be A and B. We know that the mass of the objects is the same. So MA is equal to MB, which is equal to 1.5 kgs. And we also know that both the objects were traveling in the same velocity but in opposing directions. So if you consider UA, the initial velocity of object A, to be 2.5 meters per second, the final velocity of the second object, the initial velocity of the second object would be minus 2.5 meters per second, because it is in the opposite direction. And we know from the law of conservation of momentum that the sum of the initial momentum is equal to the sum of the final momentum, right? So if you since the mass is actually the same, which means that your MA and MB is actually the same, right? It is 1.5 kgs. You can consider them together. It's 1.5 times your initial velocity of both the objects. So in this case, the sum of both the objects becomes zero here, right? Which means that the sum of the final velocity should also be zero, because only then the law of conservation of momentum will be maintained. So the VA plus VB, which is the velocity of the combined object after collision, should also be zero, just like how their initial velocities were. So with this, let's stop here, and we will take the remaining questions in the next video.
One final thing before you leave. If you wish to revise the concepts that you've just learned, please look up and try out the free Revise app bot on Telegram app. Telegram is available for free on both iPhone and Android. Also, if you did like the content that you just watched, please do like, share, and subscribe this with your friends. Thank you.